Hi everyone, this is Notes D, and this is going to be for checkpoint number 2. So there's just one set of notes for checkpoint number 2. So let's just jump right in. And I'm going to be using this method, I guess, called diamonds. So that's what we're doing in this set of notes. So the very first thing you have to put in your notes is the objective for today. So here's the objective. If you want to go ahead and pause this video and then type out this objective, you can right now. The objective or the goal for today is that you're going to read this to yourself, right? I can be given one aspect of a function, equation, tables, graph, picture, or words for a linear, exponential, or quadratic function, and find the other aspects. So what this is saying is I'm going to give you one of these things. So like I'll give you an equation, and then you will give me the other 4 things: table, graph, picture, or words. Or maybe I give you the words and then you give me the other 4 things: equation, table, graph, picture. So that's what we're doing today. Again, make sure this yellow sentence goes in our first box. Okay? And then let's make our way to slide number 2. So I'm going to talk just briefly what we've done so far in checkpoint 1. We've done tables, we've done equations, we've done word problems, and now we're going to add in graphs. So we're going to do all 4 things and put them all together. And we're going to use this thing called a diamond to help us put all these parts together. So here's my table, my equation, my words, my graph, and we're actually going to add in a picture. It's not necessarily a part of our list, but it's going to help us visualize what's going on. Okay, so here is slide 1, and here's our first example. The only thing you really need open is Desmos. Okay, now I'm giving you an equation, and then I'm asking you to fill out these other missing 4 parts: the table, the graph, the picture, and the words. So this is our objective right here. I'm also telling you what kind of equation it is. It's a linear equation. It's linear, okay? So I think I'm going to start first by taking this equation and putting it into the table. So I'm going to show you how to make a table from an equation. First things first, we are always going to have our starting value first. So you have to ask yourself and think about checkpoint 1. When you look at this equation, what number is my starting value? And hopefully you know it's this one that's not attached to x, which for us is the number 4. So how you write a starting value is you are always going to put 0 in for x, but your y is the starting value, 4. So again, you always put 0 in for x, the y is the starting value. So if my starting value was 10 right here, right? If I had a 10 right here, it would be 0, 10. If my starting value was -7, right? My starting value is 0, -7. Whatever this number is, that's going to be what goes in the table, but it's going to go in the y. Your x is a 0, okay? So 0, 4 is my starting value. Then you're going to fill out the rest of these x values, and it's always going to go 0, 1, 2, 3. Always, 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 at least from my examples, 0, 1, 2, 3. Okay, so go ahead and fill that out on your table. Now, how I move the y values, I have to know what my rate of change is. How are my y values changing? Well, when you look at this equation, what number is in your rate of change spot, or what number is right next to x? So for us, that would be the number 1. That is your rate of change. So that's telling you, and it's a positive one. It's a positive one. So that's telling you how your numbers are changing. So I start at 4. Then I'm going to be going up by 1. So that goes 5. Then I'm going to be going up by 1 again, 6. Then my last one, 7. Okay, so this table right now matches this equation because I have a starting value of 4, and then it's going up by 1. Okay? We're not done yet. We still have to do graph, words, and picture. So let's do our graph next. So we're going to make a graph in Desmos, and we're going to start by just typing this equation in Desmos. Y equals 1x plus 4. So here we go. Y equals 1x plus 4. And here's my graph. Now, I also, to kind of check myself and make sure I'm doing everything right, I'm also going to put some of these points from my table in Desmos. So the first point is going to be 0, 4. Just remember how we put in points. It's got to be on its own line. It's parentheses 0, 4. That's how a point looks. And right now, this is a really good sign because that point is on my line, which means it's right. If it's on your line, it's right. Okay, let's put in my next point, 1, 5. So remember, on its own separate line, 1, 5. And then let's do one more. I want 3 points, 2, 6. So on its own line, 2, 6. And as you can see, all 3 of those points are on my line, which means my points are matching my equation, which is good. Okay, so every graph you make, I'm going to ask that you put 3 points, just 3, not all of them, just 3. Now, here's the kind of tricky part. We need to get this graph from Desmos over into our diamond right here. Okay, so follow along and we'll do it over and over and over again throughout these notes. So what you're going to do to get this graph over to your diamonds is you're going to follow the arrows. Okay, so the first arrow I see is up here in the top right. I'm going to click on that. The next arrow I see is right here where it says it's kind of like going upwards. I'm going to click on that. And then all you have to do is click this picture and drag it over to your diamond and then just drop it in your diamond. And there is the graph that you just made that matches this table, that matches this equation. So let me show you again, or you could rewind it if you want to rewatch it. But I just followed the arrows. Here's my first arrow, the top right. My second arrow for export. And then I just clicked and drug it over to my diamond and put it down. Okay. So next we're going to go to the picture. So your picture needs to be a visual. It's got to show how it's changing. So we're always going to start with the word start. So go ahead and type the word start. And you need to ask yourself, what is my starting value again? Well, remember, it's 4. We put it in our equation. In our table, it's 4. Okay. Now we want to show 4 of something. So I'm just going to pick a random symbol like the money symbol. And I'm going to show that I have 4 of them. Okay. Again, you can pick the @ symbol. You could pick the hashtag, an exclamation point. Just don't put the number 4. Show me 4 of something. Okay, so 4 money signs. Now we're going to say that after the first time, how many money symbols should we have? We'll look over here. After the first time, I should have 5, right? They're going up by 1. So for this time, I'm going to say I have 5 money symbols. And then second time around, how many do I have? I should have 6. So I'm going to type out 6. Oops. 5, 6. And all I really want to see is 3 separate times. I want to see how it's changing. It's going up by 1 every time, a visual. All right, we are almost done. The last thing we have is words. So always start your word problems with a name. So I'm going to use the name Jim. Okay, and ask yourself, what is my starting value again? Well, it's 4, right? 4 in my equation, 4 in my table, 4 money symbols. So you need to make up a situation saying Jim has 4 of something. It could be 4 shoes. It could be 4 shirts. It could be 4 dogs. I mean, you make up whatever you want. I'm going to say Jim has 4 dogs. That's your first sentence. The next sentence should be saying how it's changing. What is the rate of change? Remember, my rate of change is 1, going up by 1, right? So I'm going to say, and you can kind of make it your own, I'm going to say every year he gets 1 more dog. You could say every day, you could say every minute, every hour, every month, whatever you want to say, but say that it's going up by one more. Okay? Now this diamond is done. We started with the equation. We just made all of the rest based on that equation.